Thanks, Rosa. So my name is Zheng. I'm from Agriculture Victoria Research. So what I'm presenting today is actually part B of the, Project 2014, where Rowan presented part A. So what we do for the Victorian components of the project is that we're trying to look at diagnostic tools for high priority pests, and in our case, viruses. So the project, the overarching project leader is Jenny Davison from Saudi, and our Victorian team composed of myself, Brendan Rodoni, and Angela Freeman. So the background for this project was that we have established in Horsham the Australian Grains Gene Bank, and with that there's a lot of post-entry quarantine work that needs to be done. Currently, there is no molecular testing for post-entry quarantine of winter cereals being imported into Australia. Most of the diagnostics involves visual inspection and some serology tests. And we want to address this gap by looking at what sort of pathogens, specifically in terms of viruses, can be imported into Australia, and what sort of molecular tests we need to develop to make sure that these pathogens do not go undetected. So very briefly, I just cover the outputs we have achieved for the project. So in terms of molecular testing, we've developed 4 national diagnostic protocols. These comes in the form of genus-specific tests, which can detect a total of 11 high-priority pests. Most of these are viruses that can be transmitted by a protist called Polymyxa graminis. This vector was previously not found in Australia when we started this project, but then sort of midway through, it was found to be detected in Queensland, I believe, and now we have a fear that once the vector is here, that the viruses it transmits can also be present in Australia. Other than that, we've also developed 12 standard operating procedures to cover specific viruses that are included in these 4 generic groups. All of these NDPs have been submitted to SFIT for national endorsement, and they're currently being adopted in our post-entry quarantine stations in Horsham for AGG testing of the winter cereal accessions being imported. So the next part of the objective of our project was to look at what are the new tools we can develop and focus on to improve our current diagnostic as well as for in-field diagnostics. And one of the things we looked at was next generation sequencing. Using this technique, we were able to successfully detect a previously unreported virus that was infecting a clonal grass that was being intercepted at the New South Wales borders. With this particular virus, we weren't able to detect it using our traditional molecular methods, such as PCR, but through NGS, we were able to do that. We're trying to incorporate this pipeline into the next phase of our project. And lastly, we were able to look at LAMP as a in-field diagnostics. We used a specific barley yellow dove virus, which is endemic to Australia, as our case study. And I think through this, we were able to develop and actually improve on LAMP. And this technology is actually currently being used in other projects as well. So thank you very much. I'm sorry I have to rush through. Feel free to talk to me after this. Thank you very much.